Morning, everyone. Welcome to today. We're starting up with a new section. So the section is differentiation, and the first section we look at is section 11.1. So in this section from the book, you are just required is going to be a read-only section, just for you to grasp the knowledge of what do we call differentiation, or what do we mean by differentiation. So here we give some terminologies that you need to understand or you need to bear in mind. So the first term here is a secant. What do we call a secant line in maths? We say that a secant line is a line that intersects a curve at two or more points. Also, we have what we call a tangent line. What is called a tangent line? We say that a tangent line is a line that meets the curve at exactly one point. So we say that then again we have what we call the slope of a line. That is the third one. Then it says that the slope of a curve at a point P, where P contains x and y on a Cartesian plane, is the slope of a tangent line at P if it exists. That means if P exists, then we say is the slope of the tangent line at a point P. Okay, so we'll now ask a question: what is differentiation? So if you remember in section 3.1, we learned about how to find the slope, and we said that the slope of any line is given as change in y over change in x, assuming you have 2 points A and B with x1, y1, x2, y2. So we say that the slope of a line is given by this, where the general equation of a line or a tangent line is given by y equals to mx plus c. Okay, so where m is a constant or m is called the slope. Okay, so this diagram just gives an illustration of what is called a tangent and what is called a secant line and what is called a slope. We say that if it meets it at one point, then we call it, so if a line meets a curve at exactly one point, is called tangent line. Then if it meets it at 2 points, is called the secant line. I will give more illustration of this on the notes that I'm going to upload later. Okay. So now we have a function. How do we determine the slope of a function f of x? So given any function f of x, how do we determine the slope? So now here goes in, we have what we call calculus. You must know what is called calculus, but my focus here will be what is differentiation. So we say that differentiation is the method used for determining the slope of any function. Then again, it says that note that derivatives is a solution after applying the method of what? Differentiation. So that gives you what is called differentiation and what is called derivatives. Then we say that integration is always the opposite of differentiation. But in this course, we will not look at integration. We will only concentrate on several types of differentiations. Okay, so we need to know how do we denote differentiation. What are the different notations for differentiation? So we say that differentiation is same as saying the slope of a line, which is denoted as dy dx, or is denoted, this is also the same as that, but in different notation. And this is another notation, d, capital D sub x, open square bracket, y enclosed braces. Okay, is the same denoted as y prime. If the function is in terms of f of x, you write it in this form, the f dx, or f prime of x, or d sub x, f of x in bracket. So all of these are different ways to denote differentiation or derivative of a function. If it's g, you call it g prime. If it's h, you call it h prime. If it's h of x, it becomes h prime of x. Okay. If it's h of z, it becomes h prime of z. Depend on what the function is in terms. You see here it says, which means the derivative we differentiate f of x in terms of x. So if the function is in terms of x, you differentiate with respect to x. If it's in terms of z, you differentiate with respect to z. Okay, so we have different types of differentiation. I would like you to just read this part of the slide, then I'm just going to jump onto, so that is all about section 11.1. Then we'll look at section 11.2. You must know that section 11.2 and 11.4 are interlinked, but here, since we are not yet up to 11.4, we will only focus on the content of 11.2. So we have different rules of differentiation. The first rule is the constant rule. So this rule is a rule that allows us to differentiate constant numbers, such as, let's say we have 100 minus 20, 10, so we denote it as a C. So derivative of a C is always 0. So whenever you differentiate a constant, you always get what? A 0. This is first example here. If y is equals to 7, then find the y, the x. If it's a function of x, assume, so we say that derivative of 7 with respect to x is what? 0. If y is e over 2, remember e is a number. If you press e in the calculator, is a number. So this is a number divided by a number. So therefore, all of this is a number. So we now have that the derivative of e over 2 is also equals to 0. Then the second rule here says the power rule. The power rule simply means if you remember, we did exponents in the first semester. So this is x, exponent of n. So if you have this function as a function of x, then we'll have that the derivative of this is you drop the power. So you drop this power, then you minus 1 from the power. So this gives us the power rule. So here goes an example. Y is equals to x power 5. So let's assume this is my x and this guy is my 5. So what I will do to apply this formula, I'm going to drop this 5 because 5 is n. I minus 1 from 5. So it becomes dropping 5 minus 1, which is 4. So therefore the derivative of this function becomes 5x power 4. Okay. So next, so these are also similar examples. So whenever you have an exponent with a negative or with a square root, it's always advisable to remove the set form before you differentiate. Okay, look at this, is x power 1 over 2. Then here, this is my n. I'm going to drop the n, then n minus 1. Also here, this is my n, is 2.5, so it becomes multiplied by 2.5, I drop 2.5, 2.5 minus 1, which is 1.5. So here my n is minus 3, so I'm going to drop minus 3, then raise to power minus 3 minus 1, which gives us equals to minus 3x minus 1, minus 4. Okay, so now this becomes derivative of x, which must always give us a 1. So if we differentiate x, this x natural is raised to a power of 1. So I'm going to drop that 1, then 1 minus 1. X power 0, which is 1. Then we'll now have derivative of x power 0. Remember, x power 0 is raised to power 0. So if we drop 0, 0 minus 1, this gives us a negative 1. So whatever we get here is not that important because of this 0. So we will also end up in 0. Okay, so now we'll have the third rule, which is the constant rule. So now the constant rule says here we have a c multiplied by f of x. Okay, so c multiplied by f of x. So I want you to know that a constant does not affect integration or differentiation. So whenever you have a constant multiplying f of x, you can always pull the constant outside. So it's being pulled outside here. Then you only differentiate f of x, where c is what? Is a constant. Okay, so an example is here. If y is equals to 3x power 4, how do we differentiate? If you look at this part alone is also the power rule. You can apply the power rule here. So what we do, we remove this 3 and isolate the 3. Then we differentiate x power 4. So differentiating x power 4, you drop the 4. Then 4 minus 1 becomes 3. So we end up with 3 times 4, which is 12x power 3. Okay, so also here they just give another example of a constant. So if you differentiate 7, you get a 0. But if you differentiate 7x, so this x is raised to power 1. So it's same as saying multiply by 1, 1 minus 1, which is 0. Then x raised to power 0 is 1. Then 1 times 7, you get a 7. Okay, so the next rule we have here is the sum rule. So if you have two functions, f of x and g of x, if f of x is differentiable and g of x is also differentiable, what is the derivative of f of x plus g of x? It's same as saying derivative of f of x plus derivative of g of x, or differentiation of f of x plus differentiation of g of x. So here is an example. Y is equals to x squared plus x plus 4, comma. Then can we differentiate this function? So it's just derivative of this plus derivative of x plus derivative of 4. So here you apply the power rule. Here also a power rule. Here you apply the constant rule. If you do that, derivative of this gives us 2x. Derivative of that gives us a 1. And derivative of 4 gives us what? A 0. Okay, so also this rule also applies to difference rule. Just simply means difference will have a minus. So we'll have f of x minus g of x. If both f of x and g of x are differentiable, then what is the derivative of f minus g? Is derivative of f minus derivative of g. So here y is equals to x squared minus x minus 4. So we differentiate this function. So it becomes derivative of x squared minus derivative of x minus derivative of 4. So this also you apply the power rule, and you apply the constant rule here. So that gives us the derivative of that, which is 2x minus 1. Okay, so here is just some mixed up examples. If y is x squared minus 5x plus 6, what is dy dx? Okay, so dy dx will be derivative of this, which gives us 2x, derivative of minus 5, which is 5x, which is minus 5, and derivative of 6 will give us what? 0. Then again, here we'll have another example that says 3x power 7 minus 1 over x plus x. So whenever you have this type of fractions or set form, it's always advisable to remove the set. So here, this one remains 3x power 7. This, we put it in terms of an exponent. Then here, we remove the set, becomes x 1 over 2. Then you now apply your power rule. So differentiating here, we drop the 7. 7 times 3, 21. 7 minus 1 is 6. Here you drop minus 1, becomes a positive 1. Minus 1 is minus 1 minus 1, minus 2. So here you drop the half, minus a half minus 1 gives you minus half. Okay, that is the end of this section. I'm going to upload more examples on the next video. Thank you very much.